So today we're going over notes 3.3b, writing equations of polynomial functions. So again, similar to 3.3a, again understanding that polynomials have different names, and it's helpful to know those names because sometimes they're written in the problem, and it's nice to know what degree you're working with because that affects then behavior and other things. So again, 0 is a constant, first degree is linear, second degree is quadratic, third degree is cubic, fourth degree is quartic, fifth degree is quintic. Again, 3, 4, and 5, those are the ones that are going to be kind of new for us. We did a lot of stuff with quadratics in the last unit. You did a lot of stuff last year in Math 2 with quadratics. Now remember, within behavior, we want our little box. So we have even, odd, positive, negative, so high to high. Minus means opposite, so low to low. Low to high, opposite of that would be high to low. So that's our end behavior. That's going to help us determine as we write our equation if we're finding that a value, is it positive or negative. So we want to write an equation that describes the polynomial graph. So we have 1, 2, 3, 4, 5 real zeros. Those are 5 x-intercepts. So there could be more than 5 zeros, right? We don't know that, but there are 5 there as we look. And they are x-intercepts, they're real numbers. So notice that all 5 of them pass through. So they are what we call single multiplicity. So that means it's going to be a 5th degree polynomial. And since the end behavior is high to low, the a value must be negative. So this is what we talked about in the last lesson, towards the end, the very last problem, right? There's not enough information to figure out what a is because I only give you the x-intercepts. But there is enough information to tell me that it's negative because I can see the end behavior. So we're going to write an equation. So y equals, and I have 1, 2, 3, 4, 5 grouping symbols because I have 5 x-intercepts. So there are 5 factors. So negative 8 is a 0. The factor would be x plus 8. Negative 4, so this would be x plus 4. X minus 3, x minus 5, x minus 7. Again, if the factor is x plus 8, the 0 is negative 8. It's what you plug in to get 0. So I'm starting with the zeros, the x-intercepts. And now I'm working backwards because I'm writing the equation. So your factors are going to have the opposite signs of your zeros. Now, usually you would try to figure out what a is, but there's not enough information. I did not give you another point. The best I can do is say that it's negative because I know the end behavior. It's negative something. I don't know what that something is. So that's why in the sentence it says write an equation. So if you were to sketch this on Desmos, it would have these x-intercepts. Right? It might not be perfectly exactly the same, but it would look very similar to this. This would have an equation, if you graphed it, that would end behavior high to low, and have these same x-intercepts. Okay, example 2. We're going to write an equation. So first, what are the x-intercepts? Negative 2, 0, negative 1, 0, 1, 0, and 2, 0. The end behavior is high to high. So that means it has to be even. Right? And it's even, it's high to high, so that means it's positive. Okay, so to write the equation, I don't know, let's call this one y2. I have 1, 2, 3, 4 grouping symbols because there's 4 zeros, 4 x-intercepts. So if the x-intercept is negative 2, the factor would be x plus 2. And then x plus 1, x minus 1, x minus 2. Again, notice it's just opposite because it's what makes it equal to 0. So if you have a factor of x plus 2, what makes that equal to 0 is when x is negative 2. So the best I'm going to do is I'm going to say that this is positive, right? Because I have to give you another point in order to figure out a. Now, there might be a few of you that might be thinking, well, can't you just use that point there? Yes, technically you could, but in the directions it says write an equation. So we're not going to use that point. So you really want to make sure you read the directions carefully. So going to example 3, write the equation. So that means I have to give you some other point other than the x-intercepts, or you have to be able to look at the graph and distinguish another point. So what are the x-intercepts? Now please be careful. Notice this is going by 2's. So the x-intercept is technically negative 2, 0 and 4, 0. And behavior is high to low. So that means it's odd and negative. What's the extra point? Either one of these would work. So I'm going to use 0, 2. The reason I would encourage you to try to use one of the points on the axes is because one of the coordinates is going to be 0. It just makes the math easier. So right now my equation looks like this. Y equals a. How many x-intercepts are there? 2. So I have 2 factors. So x plus 2, we have x minus 4. Why is it x plus 2? Because the 0 is negative 2. So what do you plug in to x plus 2 to get 0? It would be negative 2. So if the 0 is 4, the factor would be x minus 4. Now I want to double check. It's supposed to be an odd degree, but I have x times x. That's x squared. So right now I'm at x squared. That's even, but it's supposed to be odd. That's a contradiction. That means that's a problem. So I look closely at the x-intercepts. Oh, look at that. The one at 2, or negative 2, actually bounces. So this would be squared. It has even multiplicity. It bounces. It doesn't pass through like it does at 4. So now I have x to the third, which is what I wanted, right? It is odd. So now I just got to figure out a. How do I figure out a? Well, that's what the other point's for. 0, 2. There's your x, there's your y. So 2 equals a times 0 plus 2 squared times 0 minus 4. So 2 equals a times 4 times negative 4. So 2 equals a times negative 16. Divide by negative 16. So a equals negative 1/8. So my final equation is right there, circled in red. Now, does negative 1/8 make sense to the problem? Well, the 1/8 might not, but the negative should, because the end behavior is high to low. If I didn't get a negative, my end behavior would have been positive. So again, the 1/8 might not make sense to you, but the negative should, because the end behavior is high to low. We had an odd function that is negative, because the end behavior is high to low. So again, as you're doing this, please make sure you read the directions carefully. If it says write the equation, that means there should be an extra point you're going to have to plug in. If you write an equation, that's the easier part. There's no points to plug in. Go ahead and flip your notes over. So notice it says write the equation. So right there, that tells me I'm going to have to plug some point in to find a. So it has x-intercepts at negative 3, 0, negative 1, 0, and at 1, 0. It's low to low, so that means it's even and negative. And the extra point, I'm going to use the y-intercept up there at 0, 9. So right now my equation looks like y equals a times x plus 3 times x plus 1 times x minus 1. Double check my x-intercepts, right? I notice at -3 it bounces, so this has got to be squared. It's got to have even multiplicity. Now some of you are like, well, why is it not to the fourth? For us, if it's even, it's going to be squared. Going to the fourth and to the sixth, that's going to be in other classes. So for us, it's either to the first power or to the second power. Why is it to the second? Because it bounces at that point -3. So now I just have to figure out a. Again, that's what this point right here is for. Right? Here's your x, here's your y. So 9 equals a times 0 plus 3, 0 plus 1, 0 minus 1. So 9 equals a times 9 times 1 times -1. So 9 equals -9a. So a equals -1. So your final equation is what I'm circling in blue there. And does -1 make sense? Again, the 1 might not make sense to you, but the negative should. The end behavior is low to low, so it's got to be even and negative. If I didn't have the -1, I'd have an even and positive function. So hopefully that negative makes sense to you. Again, if you don't get the 1, that's fine, but the negative part should make sense. Example 5. So write the equation. Again, as soon as I read that, I should be thinking, okay, I got to plug a point in. And then they give us this information, right? We saw this in 3.3a. So they're giving us our x-intercepts. So -6, 0, -1, 0, 3, 0, 4, 0. Right? They gave us our zeros, our x-intercepts. So -6, -1, 3, and 4. And they gave us the point 2, 144. That's somewhere up here. That's that extra point. That's what I'm going to have to plug in. So my equation right now looks like A. I have 4 grouping symbols because there are 4 x-intercepts, so there's 4 factors. So x minus 6, this is plus 6. X plus 1, x minus 3, x minus 4. Hopefully that's starting to kind of click for you now. So now, right, I know that it's a quartic, right? Missed that. So 4th degree. So right now I have x to the 4th power. So I'm good, right? It is a 4th degree. So that's good. Right? Making sure you have the right degree, because that tells me that each factor only occurs one time. So at all 4 of those blue dots, my graph has to pass through. So now the only thing I need left to finish the sketch is the end behavior. So I got to figure out A. So I'm going to plug in 144 and then 2 for x. So this would be 8. This would be 3, -1, -2. So if you plug in 2 for x, these are the 4 values I get. So 144 equals A. It's going to be a positive number. So 8 times 3 is 24. 24 times 2 is 48. Divide both sides by 48. So A is going to equal a fraction, possibly, depending on 144 and 48. Well, luckily it divides unevenly. That's nice. So you get 3. And it's a positive 3. So now I have my graph or my equation there underlined in green. Right? You can get rid of these little 2's if you wanted to. Okay. So it's even and positive, so then behavior is high to high. Okay, so I'm going to start here, come down, got to go back through that point. Got to get up to this point, come down, and then go back through that point. There's my sketch. And then, as you're sketching, you know you start high, so you get to the first dot. Make a decision. Well, factor only occurs one time, so you got to go through it. So I got to get back to the blue dot, so just curve back around. How far down? It's up to you. Just curve it back down and back up. You'll figure out how far down once you move on from Math 3. So then I get to the next dot. I know I passed through. Okay, so I passed through that dot. Okay, so I know I passed through the red dot. You got to go up. Well, I got to get over to that blue dot, or the red one now. So I go to that dot. You got to come back down because I got to get to the red dot down here. Same thing, loop back up because I got to get back through that dot, and then I finish high. So again, as you go point by point, understanding multiplicity is odd, pass through it. If it's even, bounce off of it. Okay, example 6. Sketch a graph and write any equation. An equation. Right, an equation. We know that it crosses only at -3 and 5, touches at 0 and 1. That means bounces. So those factors are going to occur twice. There's 4 x-intercepts. So there's 4 grouping symbols. And is above the x-axis between 1 and 5. Okay, so we have x plus 3. We have x minus 5, we have x minus 0, we have x minus 1. Now some of you might ask, well, why is it not x plus 0? Right, x plus 0, doesn't matter. It's 0. So it crosses at -3 and 5. It touches at 0 and 1, so these have to be squared. So we have -3. We have 5, we have 0, and we have 1. Okay, and it is above the x-axis between 1 and 5. So the graph has got to do that. So that means it goes through 5, so it's got to end low. Okay. So right now we have x times x squared times x squared. So that would give us x to the 2, 4, 5, 6. So it's even. It ends low, so this has got to be low too. Right? Because it's even, so it's even and negative. How do I know that it starts low? Because even graphs start and end in the same direction. So if it ends low, it's got to end low. It's got to start low, sorry. Okay, so now that means our a value would be negative. So we go to -3. It says it passes through. That means you got to come back to 0, bounces off 0, bounces off 1, and then it's above the x-axis between 1 and 5. So I know it goes up. Okay, so that one, again, you had to piece the information together. Main thing is you start to understand the number of x-intercepts is how many factors. Then there's going to be information for you to determine. Does it pass through or bounce off of those? That information can be given to you in different ways. Last example, number 7. So it's a quartic function, so that's 4th degree. So that means it's got to be even. Passes through 0, -3. Tangent at -1 and 2, 0. Well, 0, -3 is a y-intercept. That's not an x-intercept. Okay, so we have y equals a. We have 2 x-intercepts, so we have 2 factors. Negative 1, 0, so it's x plus 1. 2, 0, so the factor is x minus 2. Now, what does it mean, tangent? So think back math too, right? For most of you, about a year ago. Right? We had circles and you worked with tangent lines. So a tangent line touches the circle at one point. So when it says tangent, that means it just touches the x-axis. So if it touches, same thing as bounces, that means the multiplicity is even. So both of these have to be squared. Remember, all of our factors are either going to be squared or to the first power when we write the equation. So now to figure out a, we need another point. Well, they gave us another point, right? 0, negative 3. So negative 3 for y, and then 0 for x. So negative 3 equals a times 1 times 4. So a equals, right, divide by 4, negative 3/4. So your final equation is the one I'm circling in gray right now. That's your final equation. So we have negative 1, 0, we have 2, 0, 0, negative 3 is the y-intercept. Going to bounce, come down, bounce, and there we go. So when you're writing the equations, understanding how many x-intercepts, that's how many factors, then you need to know, does it bounce or pass through those points? You have to figure that information out. And then how do I know if I have to find a? Well, usually it'll tell you in the directions. If it says write the equation, right, you're going to figure out a. If it says write an equation, you're going to not figure out a. Also, in order to figure out a, you have to have another point other than the x-intercepts. Sometimes that could be y-intercepts, sometimes it's another point on the graph. Make sure you answer your essential question as you're writing your summary, and then you'll be done with your notes.